let's focus now specifically on Latin America, and I'm gonna zoom in Brazil as well. First of all, I'd like to let's say, acknowledge that most of the work here has been done by Luis Bernardo, Mariana, Rebecca, who are also here. So I'm just presenting here, but the hard work has been done by them. What's the spirit here? Basically, the idea here is to explore some, let's say, scenarios that we have developed over time. So, too fast. Go up here. Okay, so I'm very briefly going to explain what's the modeling framework we have used for this work here. I'm going to very briefly talk about, let's say, global scenarios with a specific focus on 1.5 degree scenarios, then go down to Latin America and specific to Brazil, and in the end, explore what we call different burden sharing schemes, in a sense that it's not true that the only possibility for the world to deal with climate change is to go to a least cost pathway, and I'm going to explore this now. Okay, so what's the modeling framework is? The modeling framework, let's say we have a suite of integrated assessment models. So we start with this T model, which is let's say a global CG model, a general equilibrium model that produces, let's say, let's say what are the demand of services, of products at the global level. And basically the objective function here is to meet, let's say, demand for goods and services, provided that we keep the temperature up to a certain level. So we have this global, let's say, modeling of the global economy up to 2100. And these, let's say, inputs are used to fit into a very, let's say, technological explicit model, which is the COPPE model, which is also a global model that, as you're going to see, splits the world in 18 different regions, and basically you use that information to put constraints on Latin America and also on Brazil. So very briefly here, this is how the world is split in our global model, the COPPE model, and then we can see that we have Central America as one independent region. We have Brazil as one independent region, and also rest of South America as an independent region. So when I'm going to be talking here about Latin America, in fact, I'm going to be talking about Central America and South America as a whole. Okay, why this work is so relevant? In fact, Bas could have mentioned that. The ENGAGE project was the project that provided the largest share of global scenarios for the most recent IPCC report. So basically is or was or is still being a key project for the IPCC process. And out of some 2,000 global scenarios that fed into the IPCC database, we selected 5 scenarios which we call illustrative mitigation pathways. Basically illustrate, let's say, different possibilities to keep temperature below 2 degrees or below 1.5 degrees. And all these 5 illustrative mitigation pathways come from modeling teams that are represented in this consortium, just to give you an idea of how important this project has been for the IPCC. Okay. What I'm going to be presenting here is the most recent version of our COPPE model, the COPPE 1.5, where we greatly improve the representation of the oil and gas sector, which is critical for Latin America. We greatly improve the representation of the industrial sector, and we greatly improve also the representation of the shipping sector, which is led by Eduardo, who is here, and his doctoral dissertation is precisely about the work that we're doing here. Okay, let's move into results now directly. What are the results that we can get for the world, for Latin America and Brazil, using the COPPE model, which is the model, the global model from COPPE, which was one of the models used for one of the 5 IMPs of the IPCC. So what you can see here, basically, if you talk about a 1.5 degree world, basically we see different trajectories here of emissions for the different regions of the world. What's important to see here is basically for the world, what we see here, it seems that the world will need to be net zero CO2 by 2060. But from a least cost perspective, we see that, let's say, Latin America and Brazil would be net zero CO2 10 years before the world. Meaning that it seems that Latin America is providing or will be able to provide a service for the rest of the world. So this raises issue of who's going to pay for that. So basically, we're doing something that will help the rest of the global economy. So this is a key issue here. Also a key here is basically when you're talking about a 1.5-degree world, we're talking about a remaining carbon budget that the world will be able to use. And when you see out of this, let's say, some 700 gigatons of CO2 remaining up to 2100, I'm not going to go into details here because can be more than 600 or 500, depending upon if you allow or not negative emissions later on. So I'm not going to go into details here, but basically, out of this approximately 700 gigatons of CO2 remaining up to 2100, we see that, let's say, the budget for Latin America is only 43. Why? Simply because the model sees great possibilities for mitigation in Latin America. The same applies to the case of Brazil. Let's say the total budget for Brazil will be equivalent to 11 gigatons of CO2 up to 2050. Well, Brazil today emits about 1,000 gigatons of CO2 per year, a little bit less than that. So if you follow that line here, Brazil will be able to emit for the next 10 or 15 years, and that's over. So we see that huge investments will need to be made in order to allow Latin America to follow this least cost path. I'm not going to go into details here, but when you look at the global primary energy, we see, let's say, the heavy reliance of the world today on fossil fuels. 80% of all energy used in the world is fossil fuel based. And in those scenarios, 1.5-degree world, we see that the fossil fuels will reduce its share to 40%. Renewables are going to increase their share from 15% up to 50% by 2050. And in the power sector, chances are that wind, solar, and hydro will represent roughly 90% of all power generation globally by 2050. When we look at those figures for Latin America, we see something different, or not that much different. Basically, we see fossil fuels today representing 75% of primary energy consumption in the region. And by 2050, according to our least cost modeling approach, the share of fossil fuel will be reduced to half of that. This has major implications for Latin America. We know that Colombia, let's say, relies heavily on coal, Venezuela, Mexico, Brazil, the oil sector is extremely important. In the case of Argentina, unconventional gas is very important. So we see the implications for the region, let's say, to follow a least cost approach to deal with climate change. Also, the importance of renewables in Latin America, the importance of biofuels, the issue of deforestation, agriculture. So many challenges for Latin America, which are the things that we want to explore with you later on today. When you look at the global level, again, the role of transport in industry, we have a particular behavior here for transport and industry at the global level. But when you look at Latin America, we see a different, let's say, a different kind of picture. Let's say, in the case of Latin America, we see the importance of biomass-based fuels, which is very unique of the region. So we see that according to this least cost approach, let's say, the transport sector by 2050 would, let's say, rely on biofuels up to 60%. Meaning that, what about the electrification of transportation that we're seeing trends in Europe, US, China, et cetera, et cetera. So we see a different profile here for Latin America, and these are issues to be discussed because, let's say, those technologies, let's say, are globally developed, but we see a different profile in the case of Latin America. The issue of, let's say, biomass, hydrogen, et cetera, also are key issues that we have to pay attention. But anyway, we see that in any case, the situation in 2020 and the situation in 2050 will have to greatly be, let's say, changed if you were to follow a least cost approach to deal with climate change, globally speaking. Okay, this is the big picture, okay? But what we can see here is that all numbers or all figures I presented here are based on a least cost logic. What about if you try to explore different logics here? For example, what we call different fairness schemes for allocation of the remaining carbon budget. This is the work done by Rebecca, who is somewhere sitting here, is also part of her doctoral dissertation. So let us explore what would be the implications of different burden sharing scheme for Latin America in general and Brazil in particular. Basically, what we have tried here to explore are 5 different possibilities to allocate emissions for the different countries of the region. What we call grandfathering, immediate per capita conversions, ability to pay, and greenhouse gas development rights. Basically, we see here, let's say, what's the criteria, let's say, to transform these names into allocation of carbon emissions according to these key schemes for Latin America and Brazil. So I'm not going to go into details here, but for the case of grandfathering, basically we are somehow freezing what's the share of emissions of the different nations today, and somehow we keep that share over time. So this is a way to allocate emissions. Eventually, we can think about let's say, a per capita convergence over time, meaning that developed countries will need to go down in the emissions per capita, and developing countries would allow to go up, so that over time you converge, and on a per capita basis, emissions will be similar. Also, the issue of ability to pay, etc. So different approaches. And what's interesting in the case of, let's say, Latin America, and in particular Brazil, that this does have implications. So as of today, let's say, normally, when you talk about, let's say, fighting climate change, what's going to be the different efforts of the different countries, basically, almost implicitly, the logic is the least cost, let's say, logic. Okay, what's cost optimal for the globe, no matter whether or not this is cost optimal for the different regions of the world. So what we see here in the case of Latin America, let's say, on a least cost approach, Latin America should be net zero CO2 by 2050. If you apply different logics here, basically Latin America would have more time to reduce emissions regionally. So this is also, I think this is some food for thought. Let's say, what are the implications of a least cost approach as opposed to different, let's say, criteria that would be possible also to be discussed. So here you see, let's say, from a point of view of least cost, this is the carbon budget for Latin America up to 2050, which is quite limited. But according to different, let's say, criteria, eventually the carbon budget of Latin America would be much higher or would be higher. So also these have some implications of what kind of policies those countries should deploy, what the implication of that for future NDCs for the region, etc., etc. So again, let's say some food for. Same applies in the case of Brazil. So from a least cost perspective, Brazil should be net zero CO2, let's say, by 2045, something like that. But according to different logics, eventually we could be net zero CO2 20 years later. So again, who is going to pay for the difference of being net zero in 2050, which is the cost optimum for the globe, or eventually what will be the cost optimum for Brazil, which will be to delay that kind of mitigation. Again, I'm not defending any approach here, but just to show that there are different perspectives because of also specificities of the region, because of the role, as I said, oil, gas, coal, the issue of just transition, the role of agriculture, etc. So many issues, I think, that we need to take into consideration. Okay, so what we can conclude from this. So basically what we want to have here is to open for discussion based on what I have presented here. Let's say how we go down from the globe to Latin America, and also how we go down from Latin America to different countries, and eventually even, let's say, explore the different possibilities of different allocations for the remaining carbon budget. Okay, thank you very much.